Hello, let's go over the problem of the book questions that are on page 99 of your book. Number 1, what produces acceleration? It is a net force. Number 2, in chapter 4 we define acceleration as the time rate of change of velocity. What other equation for acceleration is given in this chapter? Well, that is F equals ma, or A equals F over m. Acceleration equals force divided by mass. Question 5, if the net force acting on a sliding block is tripled, what happens to the acceleration? The acceleration also triples. Number 6, if the mass of a sliding block is tripled at the same time the net force is tripled, how does the resulting acceleration compare with the original? Well, triple the force and triple the mass means there'll be no net change in acceleration. Number 8, suppose you would exert a horizontal push on a crate that rests on a level floor and it doesn't move. How does the friction act compare with your push? It is the same. They're canceling each other out. Number 9, how great is the air resistance that acts on a 10 Newton sack that falls in air at a constant velocity? It's also 10 newtons. The net force acting on the sack is 0. Okay, moving on to page. Moving on to page 100. Number 16. Does the air resistance on a falling object increase or decrease with increasing speed? It increases. The more air per second is plowed through as speed increases. Number 18. What is the acceleration of a falling object which has reached terminal velocity? 0. It's no longer accelerating at that point. Number 22. Boxes of various masses are on friction-free tables. Rank each from greatest to least. The net force on each box. The net force is the greatest on D, and it's the same for A, B, and C. Okay, which is so D has got a net force of 10 newtons. The remaining ones have a net force of 5 newtons. Compare the acceleration of each box. The acceleration A and C are the same, and they're both greater than B and D. Okay, on to number 25. Calculate the acceleration of a 40 kilogram crate of softball gear that is pulled sideways with a net force of 200 newtons. That's going to be 200 newtons divided by 40 kilograms, which is going to be 5 meters per second squared. 5 meters per second squared. 26. Calculate the acceleration of a 2,000 kilogram single engine airplane as it begins takeoff with an engine thrust of 500 newtons. That is going to be 500 newtons divided by 2,000 kilograms. It is going to be 0.25 meters per second squared. Okay. Moving on to 32. Terry says that if an object has no acceleration, there must be no forces acting on it. Sherry doesn't agree, but can't provide an explanation. They both look to you. What do you say? Well, say Terry would be correct if she said net force. So it would be correct to say that an object has no acceleration if there is no net force acting on an object. 33. When a car is moving in reverse, backing from a driveway, the driver applies the brakes. In what direction is the acceleration? Well, when the car moves backwards, the acceleration is forward in the direction of the net force on it, decreasing the speed of the car. So the car is backing up, so the direction of the net force is forward. And I think that's it for the book questions. All right. Hopefully that answers all your questions.